everybody, my name is Peter Klapper from the School of Biosciences from the University of Kent, and in this video clip I want to show you how we can use an online resource to calculate the goodness of fit with a chi-square test. Now, first of all, we looked at some data, and I observed that in one of my classes I had 67 female students and 33 male students. And I thought, okay, if this is the case, if there was no gender bias, I would expect really 50 female students and 50 male students in this case. And I wondered whether there is a gender bias, whether female students are more inclined to take this class as, for example, male students. And I was very curious to see whether this indeed is the case. So I had to formulate a null hypothesis, and I said the null hypothesis is there is no difference between the observed frequency, so between these observed frequencies of male and female students, and the expected frequency, so these frequencies here of male and female students, other than caused just simply by sampling error. And to answer this question, whether there is indeed a gender bias or whether there is not a gender bias, as the null hypothesis suggests, I used an online resource. So I went to this http graphpad.com quick calcs, and here would be the link, and if you want to scan it in, here is the QR code. And I just simply inputted my data. So let's go to this website. So here we have this website. So when you put that in, you are presented with several choices that you can use. We know that in this case we use categorical data, female and male. These are just simply categories. There are no values associated with it. We can't say that female or male is better than the other one. So here we click on categorical data, and we want to compare observed and expected frequencies as it is mentioned in this one. So we just simply click on this, say continue. And we now can enter our categories, and we use actual numbers expected. So we say female student, and we had observed 67 students and we expected 50 students if there was no gender bias. And likewise for male students, we found that we had 33 students. And if there was no gender bias, if there was a 50-50 distribution, again we would have expected 50 students. And all we need to do now is press the Calculate Now button, and it comes up with this page here, and it says value and statistical significance. So it gives us a chi-square value and degrees of freedom, and it says the two-tailed p-value equals 0.0007. Now, what does this actually mean? So I've written it out again here. So here the two-tailed p value equals 0.007, and by conventional criteria this difference is considered to be extremely statistically significant. And we remember, if p is low, h0 must go. So I think I even forgot a zero here. Since the p-value is very, very small, 0.0007, there should be a zero in here, and we have usually an critical significance level alpha of 0.05, that's 5%, or in other words, we want to be sure to 95% that we accept the null hypothesis, and we are right in accepting that. Since the p is much smaller than the alpha, we must reject the null hypothesis, and we must say that the distribution of male and female students is significantly different from what we expect from a 50-50 distribution. This can there could be several reasons for that. It could be, for example, that the subject appeals much more to female students. It could be that the lecturer appeals far more to female students. This is, of course, what I would hope for. But there could be other reasons. However, this result with a very low p-value that we just calculated from this online calculation, since this is so much lower than our set alpha critical significance level, we have to say that there is a significant difference in the gender distribution. I hope you found this useful, and I very much encourage you to use this online resource that you find here, graphpad.com, quick calcs, to calculate chi-square goodness of fit tests. Thank you very much for watching.